All right, this is lesson 2.2, angle bisectors. And you can see the goals there. I can name congruent angles created by an angle bisector, and I can use angle bisectors to find measures of angles. So I want you to think of an angle bisector in the same way as a midpoint for a segment. Like a midpoint cuts a segment in half, and an angle bisector cuts an angle in half. So just like with a midpoint, you get two smaller segments that are equal. With angle bisectors, you're going to get two smaller angles that are equal. So an angle bisector is going to create two angles. So an angle bisector just divides an angle into two congruent angles. So you see the original angle here is this one. And then what's happened when I draw this ray JC in there, we create these two different smaller angles, okay, and they are equal or congruent. Okay, remember congruent in geometry means equals. Okay, so the two equal angles then. So to name it, it just depends on what it is that's doing the bisecting. In this drawing, it's ray JC, and that is a ray. It starts at J and goes towards C. You see the arrow on the end, that tells you it's a ray. And so in this case, you would name it ray JC, but you could have put a segment in there, like just take the arrowhead off and it could have been segment JC, or you could have extended it like this, and then it would be line JC that is the angle bisector. So that name is going to vary, so you just name whatever it is that is cutting the angle in half. You're naming that particular object, okay, using the appropriate name, okay? So here's an example then. So right out they tell us, so you always need to read carefully. This should be like that, have a ray at the top. Ray JC is an angle bisector. So it's like, oh, we're giving you information. What are you going to do with that? When you hear angle bisector, you ought to think, oh, two equal angles. I'm going to have two equal angles. So it says here the measure, remember, a little m out in front of your angle mark indicates measure. So the measure of angle AJC, so if you trace AJC, it helps you name it, AJC. Let's do it with a highlighter. So here's AJC. Oops, that doesn't look like a highlighter. That does. There we go. So there's AJC, and it tells us that angle measure is 42 degrees. So I'm going to put 42 degrees in there like this. Then it says find the measure of angle CJB. So they're really asking for this angle. And the measure of angle AJB. So now they're asking for two different angles because in this picture there are actually three angles. There's the large angle AJB that they want you to find the measure of. There's one small angle AJC that is 42. Therefore, angle CJB must also equal 42. Okay, like that. Well, then you can see that the entire angle would just be both of those two added together. So 42 plus 42 gives us the measure of angle AGB, or 84. Okay? So again, JC, little arrow on the top there. JC is an angle bisector. This time the measure of angle AJB is 36. Find the measure of CJB and AJC. Give that one a try. And hopefully you paused the video and did this problem. And so what I've got here is this large angle this time is 36 degrees. So the large black angle is 36. JC is an angle bisector. That information tells me that it creates two smaller congruent angles. So they're going to share 36 equally. So you're going to take 36 and you're going to divide by 2, and that's going to give us the measure of each angle, and that's going to be 18 degrees. So CJB is 18 degrees, AJC is 18 degrees. Okay? Sometimes they get a little more complex than that. You know, those are simple ones, okay? Once again, we have JC is an angle bisector. So when I hear those words, I have to think two equal angles. They're telling me AJB, that's this angle again, is 13 x plus 5. And then they're saying that CJB is 6x plus 4. And they want us to find the measure of AJC. Well, what am I going to do with these two expressions, the 6x plus 4 and the 13x plus 5? I need to write an equation, but what do I put on each side? Are those two things equal? No. I know that 13x plus 5 is or equals twice the measure of 6x plus 4. It takes two 6x plus 4s to equal the 13x plus 5 because this is the smaller angle. So this angle times 2 gives us the large angle. So I'm going to write that equation out here. And so whenever you say is, that's always where your equals go. So if you say the large angle is twice the smaller angle, then I just put in the expression. The larger angle was 13x plus 5 equals 2, and the smaller angle is 6x plus 4. And let's go ahead and solve that. So I got to start by distributing 12x plus 8. That's just doing some distribution there. And I got a 13x plus 5. Well, I got x's on opposite sides, and so I need to get those together. I always move the smaller of the two, and that's the 12x. And so I have x plus 5 equals 8, and then I'm going to get rid of my 5. So I get an x value of 3, but that's not what they asked for. They asked for AJC, and well, isn't AJC just the same as CJB? Yeah, so let's take CJB's expression, 6 times x, which is 3, plus 4. So this is going to give us the measure of angle. I didn't leave myself enough space there, did I? Just put it over here. That's going to give us the measure of angle AJC. So that's not 9, 18, right? 18 plus 4. So 22 degrees is the measure of angle AJC. And what if I ask for CJB? Well, it's also 22. What if I ask for AJB, the large angle? Well, that would be 44. You could even plug 3 back in there and see how that works out. Look at this. So if I put 3 in there for x, I get 39 plus 5, and that's 44. A half's 22, so I know I've done my math right there. Okay. So you're going to find a quiz is link, and you go ahead to that quiz is, and it's going to give you some practice on angle bisectors.